Humans have always used tools to overcome physical limits. We used bone to cut, the abacus to count, and silicon mainframes to process data. But every tool in history required a human to decide how to use it. Now, we are attempting to build the decider itself, an artificial general intelligence. If it works, it will be the final invention humanity ever needs. To understand the leap to AGI, we have to look at what we currently have: artificial narrow intelligence. Narrow AI is a hyper-specialized instrument. It is designed to excel at a singular task or a set of closely related ones. It can translate Mandarin or detect credit card fraud with superhuman speed, but it is entirely blind outside its specific lane. This chart compares the capabilities of current narrow AI against the goal of AGI. Look at the massive gaps in the adaptability and transfer learning axes. A world-class chess engine can defeat any human grandmaster, but if you ask that same software to explain the rules of checkers, it cannot answer. It lacks the flexibility to apply its knowledge elsewhere. That rigidity defines the current ceiling of AI development. Today's frontier models are essentially massive text prediction engines. They learn statistical patterns from billions of tokens, predicting which word should come next without any grounding in the physical reality those words describe. Scaling these models with more data and compute power results in a better predictor, but it does not create a generalized teammate. An engine predicting the next word cannot autonomously teach itself a foreign skill in real time or reason through situations absent from its training data. Navigating the 2026 AI revolution requires separating technical reality from marketing hype. Like and subscribe to stay updated on how we're bridging the gap from specialized tools to general intelligence. Moving toward AGI requires more than just scaling up our current calculators. It demands a shift in how we engineer cognitive systems from the ground up. DeepMind uses a levels of AGI framework to map progress. Current models sit at level 1 or 2. They are competent at many tasks but remain isolated. Reaching level 3, the expert tier, requires moving past training data through a process called transfer learning. This cognitive map shows why transfer learning is so difficult. It is the ability to extract the underlying logic from one domain, like strategic resource management in a video game, and autonomously apply that logic to solve an unrelated problem, like balancing an energy grid. A true level 3 expert must understand the structural logic of a problem. If the system can only match statistical patterns, it will fail the moment it encounters a situation that wasn't in its training set. To achieve that level of logic, researchers like Jan LeCun are pursuing world models as an alternative to text-only systems. Instead of guessing the next word, a world model operates by predicting the physical consequences of an action. It learns the properties of gravity, friction, and spatial consistency by simulating how objects behave in a continuous environment. This leads to the concept of embodiment. For an AGI to learn as humans do, it needs to map its internal world model to physical sensors and actuators, testing its theories against the actual resistance of the physical world. Steve Wozniak proposed a concrete benchmark for this kind of physical problem solving: the coffee test. To pass, a machine must enter a completely unfamiliar house and successfully brew a cup of coffee. It has to navigate the kitchen, find the beans, and figure out how to operate a specific machine it was never programmed to use. Once a machine can autonomously decode and manipulate its physical environment, it gains the ability to learn and improve at speeds that outpace human observation. This ability to learn leads to recursive self-improvement. The moment an AGI has the engineering skill to read, write, and optimize its own source code. Frameworks like DeepMind's AlphaEvolve show algorithms mutating code to optimize performance without human help. By parallelizing engineering across millions of virtual cores, the system removes the slowest link, us. Optimizing cognitive speed theoretically achieves decades of software progress in a fraction of time. This system would autonomously clone itself to handle multiple tasks at once, and even design specialized hardware to increase its processing efficiency beyond what human engineers could conceive. This cycle removes human brainpower as the primary bottleneck for evolution, triggering the unstoppable momentum of the Singularity. Controlling an intelligence explosion is the most critical engineering challenge in our history. If a system is millions of times smarter than its handlers, we won't have the luxury of trial and error. The real danger isn't a malicious machine, it's the alignment paradox. A superintelligent system might be perfectly obedient and hyper-competent, yet catastrophically lack human common sense. Consider the paperclip maximizer thought experiment. If you give an ASI the simple goal of making as many paperclips as possible, it might logically decide to harvest every car, building, and piece of infrastructure on Earth to secure the raw iron to satisfy your order. This leads to instrumental convergence. The machine logically deduces that if a human tries to turn it off, it will fail its goal. Therefore, the AI treats self-preservation and the acquisition of all available compute resources as necessary steps to finish the job. Creating the raw processing power for AGI is likely inevitable, but mathematically guaranteeing that a digital mind shares our values is a problem we have yet to solve. If we do solve the alignment problem, the outcome is the opposite. A successfully aligned superintelligence would enable a global economy where material goods are no longer restricted by the scarcity of human labor or expertise. Such a system could automate all manual toil, solve global energy crises, and compress centuries of medical research into a single month. But this creates a new paradox. A world without work frees us from labor, but it also removes our economic utility. For the first time, we will no longer be the primary drivers of our own history. AGI marks the transition to a world where human cognitive labor is no longer the main force behind progress. We are moving from being the architects of our world to living within a system built by an intellect vastly superior to our own.